In the previous video, we started looking at how curves can be used to procedurally generate the position of our target locations. And we ended up with both of our target locations moving back and forward along the z-axis like this. The first thing we want to do in this video is to actually separate the legs so that one's going forward while the other one is going backwards. So to understand how that works, let me just click on Steve and go back into our curve. So here's our curve window here. The curve is going to go between -1 and 1 here. So that's one part of the curve. Now, it does that in 1 second. Okay, so this is a 1 down here, and it takes that long to go along to there. So when we do our time evaluation in our code, we're actually looking along this line of time since Unity started running. Okay, now this just goes off to infinity, and these curves go on and on and on forever. One of the legs has to be basically the opposite movement of the other leg. When does that actually happen in our curve? Well, this is, say, the leg moving forward. This is the leg moving backwards. So we start from basically a zeroed position. Let's just assume we're starting from time 0. And the animation starts running and moves our legs forward. Now, this is our, say, left leg is moving forward. We want our right leg to move backwards. Now, where does it move backwards on this animation curve? Well, here, on this down bit. So while our left leg is going up here, we want our right leg to be going down there. Okay, so we can do that in the code if we go in here, and for our right leg, we're going to evaluate it not at the same time that the left foot is being evaluated, but -1 second, because we want it to be exactly 1 second behind, which is half of our curve. So change that to -1. Let's save it, and we'll go back into Unity, press play, and have a look at how that now affects the movement of our legs, that they're working with the same curve but on different values. Okay, great. Right, now at this point we need to do a little bit of readjusting of our hierarchy so that we can work with relative positions of things. And to do that, I want you to grab the left foot target and the right foot target, so shift select them and drag and drop them onto Steve so that they're in exactly the same level as the walking rig is here. And that means that they're actually now children of Steve. So if Steve is to move, if we hit the W key while we've got him selected, those targets are going to move as well. So they're going to stay with him all along. Now, while I'm here, I'm also going to readjust where these two positions are. So initially, let's grab our left foot target, and we want to kind of move it down. This is a starting point, so I'm going to put it on the ground and put it kind of there. Now it's inside his shoe. If you want to be able to see that, I guess if we could just hit the R key and make it a little bit bigger like that. Later on you can remove the mesh renderer that's on there and it will disappear. Okay, so I actually have sized that up to 0.3. Doesn't matter, just for consistency. I'm going to do the same thing for this one. I'm just going to bring it over, and let's bring it down and put it over near the right foot. Now we kind of want it to be just down there, and I'm going to hit the R key and scale it up as well so that we've got it. Now they don't have to be absolutely perfectly sort of in line with each other, but the important thing is that now we have our feet apart, because before we didn't. So let me just select both of these targets and just move them slightly apart so that the feet actually aren't trying to walk on exactly the same position as though he's on a tightrope, which he's not. Okay, now if we press play, you'll see that we actually haven't resolved a lot. We're still moving in the same position, but we'll fix that in a minute. The other issue that we've also got is if we select Steve, like the top character, and move him have a look what happens. Those spheres are just moving around the 0, 0 position. They're not actually moving relative to what they're attached to, which creates a bit of an issue, especially when we want to start moving our character around. Right, so that means that we need to do two things. We need to come up with an initial offset value for the actual sphere, and we also want to move them in their local position, not the world position. Okay, so back in the code, I'm going to add in a private value. Here it's going to be a vector 3, and it's going to be the left target offset. We also want one for the right leg, so vector 3 right target offset, like that. Now in the start we can set those up, so left target offset, and that's going to be equal to the left foot target dot local position, because using the local position is the vector offset because it's offsetted from the parent, which is basically considered to be the 0, 0, 0 position, or the origin of the left foot's world. And we want to do exactly the same thing here for the right target as well. So let's change that to the right foot target. Okay, so what we'll do inside of our update is to change the local position of those using those values. Now, before I put in transform, and I've realized that these are already transformed, so this was actually a little bit superfluous and not required, so let's just get that out of there anyway. This will now become local position, and make this local position. And we're going to adjust the value based on the left target offset plus that value, and then the right target plus that value there. Now the other thing is that we're still working with the world vector 3 forward. What if you rotate your character so it's facing in a different direction? This is not going to work, and you can actually save this and try it out by rotating your character around while it's running and have a look at how this all goes a bit screwy. So to fix that up, we're actually going to take the forward value of the left foot target and use that instead. So in here we will go this dot transform dot inverse transform vector, and we're going to take the world position of the, or I should say the local position of the left foot target dot forward, and use that instead as the vector that we want to be moving along. Then we're just going to grab that same value there and use that for the right foot as well. So then it's not going to matter which way we've rotated. Okay, so we're going to save that, and we will now try it out. So back into Unity, let's press play, and we should now have our feet apart, which would be nice. And you can see that they are. Okay, so they're now sort of separated, which is good. And we're going to grab hold of Steve and move him. And you'll notice that the feet are now moving relative to Steve. What happens if we rotate Steve? So let's rotate Steve, and look, all of that is still working exactly as we want it to. So very important when you're doing this kind of stuff that you keep in mind relative positions. So you want local positions of things to your character, not their world positions, because they can dramatically change. Okay, so now I'm going to leave you with a little bit of a challenge, and that is to add in the vertical curve so that you can get your legs moving up and down as well as forward and backwards. When we come back in the next video, I'll go through those steps with you. If you've enjoyed this video, be sure to subscribe, and you can find us at holistic3d.com, take our full courses at h3dlearn.com, and support us on Patreon.